Good evening, ladies and gentlemen. You know, this is your host, Proud Lame, certified doing no game over here, Christian Paul from the Nerd Chronicles here. And this is like another try, fail, test run part 2 when it comes to linear use course prediction data set. And I was actually trying to get it to go on stream, good streaming on Twitch due to that, but because it ran off so much memory on the computer that fast that it causes overload, I want to try and get a recording in so I can try and set it up on YouTube so that everyone can actually see a full glimpse on a basic classification problem that we can do a simple prediction on. We already did the data visualizations mainly on Tableau, so not much is actually going to be done. I already did some add-ons just in case, so you definitely see those. All the information you will definitely see definitely on my GitHub, where they have an independent site titled India's Used Cars Prediction Dataset, or India's Used Cars Dataset. You'll be able to find it up there. Now, let's see if we can try to load all the data we have here. These are actually classification data sets and classification models that we will be running. So we'll just try and get straight to the point here. Now we got that set here. All right. Load up the data set. Print out the saves, see the sizes, get the heads down, see what they are. And we know basically what these guys are. Scroll all the way down. On my right, this is what we are seeing with the rows. Not really much rows to actually work with. And we describe what these data sets are about, since we know it's a classified data set. Technically, we have a bunch of counts here. Obviously, we have like 302 characters and rows that vary. Some unique, some ordeal that we can figure out. And they got frequencies based on which is like the most repetitive. That's what we mean by frequency here. Let's get rid of the self-remove because we need to convert this data set from objects to floats. Get rid of these guys here, do some cleanings, do some cleaning stuff out there, get rid of all this stuff that has the words, get them out the way. Now let's convert it, right? Convert the string to float. Get that out the way. All these, I already did these early on. You can actually see those on GitHub. Again, now let's see, we can print the current data set and see what's looking like here. All right, boom. 301 columns you're working with. Now let's do some test options, run the data set, see what we get. Alright, knock them out. We got a bunch of integers and strings and a number of folds used. So what we're going to try and do with the algorithms, logistic regression, linear discriminant analysis, k-nearest neighbors, classified version, decision trees, classified version, native Bayes, as well as supporting vector kernel. Let's try those with 6 algorithms out and see what we get. Okay, already set. Now let's evaluate and compare. See what we get out there. Alright, so far we got the outcomes. Basically, a lot of you guys are coming off in the 95th percentile, LDA 94 percentile, KNN 96 percentile, 91, 92%. Rounded off to support vector kernel is 96%, basically performing the best so far. KNN 0.958333. The other guy we know is for vector kernel 9.58333. Now if we compare which one has the means here, you can see 2.6352. And we have support vector kernel is basically the same thing. So we have those sets. Now let's see if we can try to compare those to see which would be better. So far we have a tie. And we actually see the chart here, which we will run. Alright, let's go look at the plot here, and this is what we're seeing. We have about the same variables here. Now let's add some ensembles. We got ADA boost, radial boosting, random forest, and extra trees, all classified versions. Let's see what we get out of those. Okay. 85th percentile for ADA boost. Gradient boosting man 95th percentile, random forest 95th percentile, 96 percentile so far as k-nearest neighbors and supporting vector kernel. Basically going with the tie. We're just gonna pick the SVM model here, and then we're gonna add in the KNN and see what we get and see if we have another value as well. So these are the comparisons that we see here. We got the scalar model that's there. Basically get those manipulated, but we don't have to really worry about too much because like 300 stuff. About 300 characters we have to worry about, and we'll see if we type in the dataset here. And so far, it's coming out for the 98th percentile that's shown. Now, if we try to focus on K-name as classifier, let's see if we try those out. Let's see what we can get as well. Let's try to copy this guy and see if we can make a thorough comparison. Let's see what outcomes we get out of this. Now, KNN. SVM 0.98360655737700492. Very precise. Weighted average there. FL score is there. Same thing. 98360655737700492. Very identical to T, which is very, very interesting. Very, very interesting. So, we're going to leave the conclusion is that we'll definitely leave for the general public to decide which would be a better fit or a better model. If there's any other questions that you guys would definitely like to ask, free to discuss this here. Feel free to actually discuss any further details if you want to actually dig into those analyses a little further and actually go to these individual graphs, see which cars are actually performing well so far. This is basically for the general public of any of the make a public decision or public opinion based on the data that's given to see which car in their mind or in their opinion would feel right for them to use, which used car more specifically would be best for them to use for the years to come. So with that, Christian Paul is signing out, about to hit the sack, about to get ready for bed. I will see you guys on the next one very, very soon. Y'all take care. Deuces.